Yeah, welcome, dear participants. I hope I'm now online, everything works well. Welcome to our Nova session about the latest market reports and trend reports from Nova on alternative naphtha, advanced recycling, bio-based polymers, and bioeconomy in China. All the main authors of the reports are here today, so I'm very proud that they can present their results. And I give a very short introduction. My name is Michael Karus, founder and CEO of nova-Institut. A very short introduction in nova-Institut and what we will see today. This is the program today. So we have 4 presentations. It's the 4 latest market reports from nova-Institut. And first, we talk about alternative naphtha, because naphtha is about bio, CO2, and recycling, covering the whole sectors. Then we turn to recycling. Lars Krause, first it's Jill and Tweddle, then Lars Krause. And the number 3 is bio-based building blocks and polymers by Pia Sosinski. And last not least, China and Sang, a deep dive in the Chinese market situation. And then I will finally wrap up. I'm the moderator today, so if you have any questions in between or after the presentations, please put them in the chat. The presentation will take 15 minutes plus 5 minutes discussions. And so use the opportunity today to give your questions directly to the main authors of the reports. So a very few slides on nova-Institut. Nova providing different services, technology and markets, sustainability, mainly life cycle assessment, communication support, and economy and policy. But today, the focus is on the department of Achim Raschka. This is technology and markets. And we see at the first bottom points here, market research and market trend reports. This is what's about today. And I will not go in here in more details. They offer a lot of other services here. You can see it. And even today, also business plan development. So if you need support from Achim, please reach out to him. You see here the email. nova-Institut is working for a lot of companies, about 500 companies we worked the last 10 years. And it's very impressive that now more and more brands reaching out to us for fossil-free plastics or defossilization of the chemical industry. So all about the topics today. There is a big interest from international brands, but of course also from chemical companies. Here you see a lot of chemical companies, and these are our typical customers because next to the brands, because we need them to do the transformation. If the chemical industry is changing their feedstock options, and we hear a lot about this today, then the whole value chain can defossilize. These are reports we're talking about. So the top 4 are the latest we showing you today. The numbers showing the order, naphtha, recycling, advanced recycling, bio-based building blocks and polymers, and then China. And very few other services. Renewable carbon use, you see on the bottom the link, is the biggest new system in the world on chemistry, renewable chemistry and polymers. It's an outstanding page, and we have every day about 5 to 10 news here, everything free of charge. So please take a look here. You can also take an abonnement to get all the news every day in your email. Another service also interesting for many of you is this renewable carbon companies, a database, meanwhile 143 companies free of charge. You can find partners, suppliers in all the different sectors. So it's also very useful to use it. And last but not least, upcoming conference, I will show this at the end again. Cellulose fiber conference, CCU conference, and renewable materials conference coming next year. And the new date for the recycling conference I also added here. But now enough for introduction. Now we come into the first. I go back here to the first report: alternative naphtha technology, market status and outlook. Jill and Tweddle. And again, if you have any questions in between, put them in the chat. I will take the questions then after the 15 minutes. Jill, you have the floor. I will stop sharing here. You can take over.
Yeah. Okay, good. So hopefully my screen is clear. Yes. Okay, thank you. So we'll start. So as Michael already said, we're going to talk now about the alternative Naphtha report, which was published recently this year. So, yeah, as you saw in the earlier slide, this is what the report cover looks like. What we're talking about is defossilization of the chemical industry. We really have to find alternatives to fossil-based naphtha. So we're talking about a concept that makes use of existing refinery, steam cracking, chemical infrastructure, and where we can replace a portion of the fossil-based feedstocks with renewable carbon. And of course, there are various options for that. And that's what the report talks about in its 188 pages and tries to give a comprehensive view on the growth in capacity for these alternative sources of naphtha. So what are we talking about with alternative naphtha? So we have here a basic diagram, very simplified, for refinery and petrochemicals operations. So we show a refinery, we show a steam cracker. And at the moment, we use a lot of light naphtha from the refinery fed to steam crackers to make chemicals. So we're talking about replacements for that, light naphtha, C1 to C6. We're talking about replacing feedstocks to refineries, which end up being able to create reformate and feeds to aromatics to replace the existing heavy naphtha that's converted to reformate from fossil flows. Yeah, so renewable naphtha can be added to the cracker, or we can add materials to the refinery, as I mentioned. So in this diagram, we want to show all the possibilities, or the main possibilities at least, for being able to replace fossil-based naphtha to the steam cracker and materials we're going to put into the refinery. So it's important to take into account that there are several ways to do this, and we're showing here 5 main routes, and this is what the NOVA report focuses on. It looks at the possibility of directly feeding some vegetable oils or replacement oils to the refinery in route 1, which is co-processing. It looks at taking vegetable oils and fats and other waste oils, let's say, and using those in the HVO and HEFA type of processes which already exist, mainly to produce renewable diesel and sustainable aviation fuel. And then the byproduct, renewable naphtha, and some of the renewable diesel that's created can also be used in the chemical industry to feed the steam cracker. Then we also have the possibility to carry out pyrolysis. So let's say advanced recycling on plastics or mixed wastes which contain plastics. We create some pyrolysis oil. We can put the pyrolysis oil to the refinery, perhaps with some upgrading or perhaps just in small volumes. We can also upgrade the pyrolysis oil, and we can use this as an alternative steam cracker feedstock. And then finally, but not least, what's coming more into focus is taking biogenic materials or taking CO2 and hydrogen via electrolysis, creating syngas from these materials, carrying out the Fischer-Tropsch process on this syngas, and then also generating fuels, but ending up with some byproducts that can serve as steam cracker feedstock. So this is the essence of the report. It covers these routes to steam cracking. And finally, I also want to mention that we also briefly talk about a future possibility where there can be some renewable naphtha from the alcohol to jet processes that are coming along. Yeah, so the refinery can be fed. Renewable naphtha, renewable diesel, route 2 coming from the hydrogenated vegetable oil process, or the hydrogenated esters and fatty acids. So here we have made an estimate of the market situation, the volume of material that's coming from this route and being fed to steam crackers. So we think it's somewhere under 1,500 kilotons in 2024, and all that material is supplying additional carbon, additional renewable feedstock into the chemical systems downstream. So just to be clear, we're talking here about the process that creates renewable diesel, renewable naphtha. It's not the same as the biodiesel process. This is the HVO and HEFA process. And as we said before, naphtha is more or less a byproduct, a 10% or a 10% co-product. Let's go. So how does it work? So this is a block diagram for the HVO and HEFA process. We take some oils, fats, and greases, and we carry out processes where we add hydrogen and we deoxygenate the materials. We carry out some isomerization or hydrocracking to get the right chain length materials and the right boiling point ranges. And then we have a set of products. So we can feed some bio-naphtha to the steam cracker. We can feed some renewable diesel to the steam cracker, but also the other materials, the sustainable aviation fuel that's generated, the renewable diesel, they can be used as drop-in replacements for fuels in the existing market situation. Pyrolysis oils from plastics. So these are shown as routes 3 in the initial diagram that we looked at. So yeah, we can take plastics, we can take mixed plastic wastes, and there are a large number of pyrolysis processes which end up generating pyrolysis oil, a dark brown colored material with a wide boiling range, high levels of unsaturated hydrocarbons, and high levels of contaminants. So with that, there are 2 routes to processing these plastics pyrolysis oils to chemicals. We can carry out some upgrading on that material, and we can feed the material to the steam cracker, or we can feed some of the material to the refinery where it's processed in existing hydrotreating, hydrocracking units or fluid catalytic cracking. And so in that way, the material is also treated and can enter the system. Of course, low volume dilutions of, let's say, unupgraded material are always possible, and you hear about this a lot in the market. Of course, it depends on the composition, it depends on the configuration of the steam cracker, and if you're only adding small proportions, it's much easier to handle than if you would like to increase the volumes. So again, a quick estimate for the market size. What are we talking about? Now here we're talking about the capacity to produce pyrolysis oil from waste plastics. And I have to emphasize this is capacity based on announced projects. And then we say, okay, the pyrolysis oil output is so much, and we're calculating that on the basis of a 60% conversion of input plastics to pyrolysis oil. Of course, if we would then carry out some fractionating, some upgrading, there will be some more losses to take into account. These could be fairly small if it's for upgrading alone. So we're talking about an absolute capacity at the moment of under 1,000 kilotons a year. Of course, this would assume that all plants that are online are operating at capacity. We know that's not the case. And we know that what's important in pyrolysis is that we have relatively small processing plants of the order 20 to 50 kilotons a year of waste feedstocks. The kind of model that exists is a partnership model between the pyrolysis oil producers and the refineries or the steam crackers who use that material. Okay, next I want to talk about some of the market drivers, particularly for pyrolysis. I think it's a little bit different to some of the other routes, mainly because it's seen as a way of treating plastics and thus reducing the leakage to the environment, and as well to meet the sustainability concerns and commitments of brands for recycled and renewable contents. And yeah, we're closing the loop, let's say, on the post-consumer waste and taking the material back to plastics. So that makes it especially interesting. Some of the disadvantages, of course, are that it remains quite small scale at the moment with a low level of technology development in some cases. And yeah, the availability of feedstock is a concern still. we're not really talking about legislative issues in detail here, but we are awaiting acceptance of the mass balance and attribution approach in European legislation for pyrolysis oil-derived plastics, that will be able to be counted as part of recycle quotas under certain situations. So that's really expected to provide a boost to pyrolysis and to alternative naphtha from those routes. Finally, alternative naphtha via carbon dioxide and the Fischer-Tropsch process. So route 5 in the initial diagram. Here we can see that it's possible to take some carbon dioxide from the atmosphere via various routes and combine that with hydrogen to generate some syngas. The syngas is then processed by the Fischer-Tropsch synthesis, and we create what we're calling here synthetic crude oil. And again, by treating that and by carrying out some fractionation, we end up with some fuels, with some SAF, sustainable aviation fuel, with some renewable diesel, and we have as a co-product or a byproduct, again, some renewable naphtha. And this provides a further feedstock for the chemical industry. So there are regulations that demand a certain quota of sustainable aviation fuels and also synthetic aviation fuels made from CO2. And this is really a driver for the production of SAF via this route and the availability of some naphtha as a byproduct. Where do we stand at the moment with this alternative naphtha from CO2? Well, there are some demonstration facilities and small-scale projects which are expected to be operational in 2024, as you can see in the diagram here. We have a large list of projects that in theory could be operational between 2026 and 2030. The interest is definitely growing. And so these are really projects we need to watch to see how this is going to come to fruition. Production volumes are currently very low, but yeah, there could be projects which provide significant volumes in the near future. So finally, I want to just show the table of contents here for the report, which you can look at offline. You can see what's in the report. And thank you very much for your attention to this brief presentation.
Yeah, many thanks, Jill, for the insights in the report. We have a lot of questions, but before I want to give 3 additional information. The first is there was a question in the chat, and please put everything in the chat, not in a Q&A, but everything in the chat. Whether you can receive these presentations later, yes. Just write me an email, michael.karos@nova-Institut.de, and then I will collect the presentations and all the requests and send to all of you the version. Another information is that 3 of the 4 reports have also free of charge short versions in the net under renewable-carbon.eu. So you can find also a lot of information already free available. And last but not least, the best information, we have a winter special running. So every report from now till January, you can buy with -20% discount. Now we come into the questions. The first question is the amount, do you know the amount of fossil naphtha consumed per year? Jill, for Europe, I have in my mind 50 to 60 million tons naphtha in Europe. Do you have similar data?
I don't have it to hand, but it's that sounds right, or maybe a little bit lower now, given that we're seeing some refinery closures over the last refinery cracker closures over the last few years.
Okay, well, 50, 60 million was the data for a few years ago, so perhaps it's now about 50 or so. Yeah, then the next question is, does the study mention the yields of the different processes?
No, we don't look in depth at the individual chemistry of the processes. So we're looking more at an overall level of output, trying to assess the capacities of plants and looking at what that means for naphtha to the market.
And the next question is, what does high level of contaminants mean in percent? So levels is high level. What does it mean?
I mean, it's different for every particular contaminant. In the report itself, there's a table which gives some, let's say, typical compositions of pyrolysis oils coming from plastics pyrolysis. Of course, it really depends which kind of plastics input you have. It can be quite varied, but for some things, it's ppm levels that cause a problem. So things that could be catalyst poisons like silica, for example, and then other things. There are limits on the concentration that can be fed to a typical steam cracker. So this is all around the matchup between what comes out of the pyrolysis and what the individual steam cracker can accept.
Okay, thank you. And then there's a question, I'm not sure what does it mean, but perhaps you understand the question. Paralyzes, oh, it's going so fast here. So many questions. Paralyzes and the combination of PA/PET question mark.
Yeah.
Yeah, can you comment this?
Yeah, well, some things are less desirable in pyrolysis than others. And yeah, those are things that are better not pyrolyzed, and there are other, which Lars is going to talk about, I think, other better ways perhaps of treating those plastics. So yeah, you don't want PET in your pyrolysis if you can avoid it, let's say. But yeah, there are all kinds of different pyrolysis processes, and there are companies that say their process can handle different things. So this is a point. It's there's a lot of variety there.
And then, and perhaps also in the next presentation on chemical recycling, Lars can also comment this. The other question is about the project selection. Did you track project status for the oil projects, e.g. if FID is reached, or is it assumed that all announced projects will be developed until production?
Yeah, I mean, the way it works is that we picked up on all announced projects, trying to take into account that some projects are announced and we know at a certain point that they're not going to go ahead, but it's not specifically on FID. So of course, the list will be longer than those projects which ultimately will come to fruition. And this is a list that needs to be continuously updated. But of course, it's better to know what's out there and what could happen than to try to deselect too quickly.
So the idea is also that we make a yearly or 2-yearly update of this report, because we are collecting information all the time. And so, yeah, this is the status we found so far. But an update will, of course, look deeper to the projects, new projects and old projects. Then the question is on LCA data available to understand the impact of each route. I don't think there are solid LCA data so far available. What is your view, Jill?
I think the amount of LCA data is highly limited. I think that's correct. I think this is a topic that I would recommend that you to discuss further with our colleagues in the sustainability department at Nova. But yeah, I think that's basically the status. We're waiting for some larger scale implementations or some longer online time before we're going to get a good, or at least a better view on some of this data.
Yeah. Then we have a very long question here. Another prominent technology in regards to HEFA is power to liquids.
Yeah.
Do you have estimates on output of bio-naphtha for that technology pathway? Perhaps that's the first question.
Well, essentially, this is covered in the Fischer-Tropsch route that we're looking at. So we're looking at using electrical power to capture CO2, and then we're going to convert that into fuels, and we're going to have some naphtha. So essentially, that's covered.
The next question is also an interesting question. Is the total bio-naphtha capacity available to chemicals, or will they be reprocessed into hydrogen or blended to fuel in the aviation market? Do you have an estimate of the share of these three destinations of bio-naphtha?
Yeah, well, what we did is we looked at all the producers of hydrogenated vegetable oil or outputs, and as you mentioned, it's true that not all of that material finds its way into the chemical industry. There's vastly more material produced, especially, let's say, in the US, where it's not straightforward to put that material to crackers because they're set up for light feeds and not set up necessarily for naphtha. So the report contains an estimate of the volumes of the volumes processed by the HVO HEFA process, and then there's specifically an estimate of the amount going to steam crackers from companies that are offering this material, or let's say have partnerships with steam cracker operators that accept this material.
And I think the main point is here, how will the framework develop further? So far, the kerosene market, aviation market is very attractive due to quotas.
Yeah.
But there are discussions in the Commission also to have perhaps some similar systems for chemistry. So that will have a huge impact, of course, on the allocation of the naphtha to different markets. Yeah, we have now the 20 minutes finished, so there are still a lot of other questions. Perhaps Jill can take a look to it later. And then you can also send questions or requests to michael.karos@nova-Institut without an E at the end, .de. And then I can pass it over to Jill. Many thanks, Jill, again. And please stop your screen sharing so we can come to the next speaker. Is Lars Krause from nova-Institut. With his report mapping of advanced recycling technologies and their global capacities. Lars, you have the floor. Yeah, it was full screen. Now it's not full screen. It was a second before full screen. Lars? Are you available, Lars? What happened? Lars is frozen. Oh, here you are.
I had some technical issues, but I'm back here again.
You can make full screen, yeah. Okay, Lars, the floor is yours.
Okay, hello everybody, and welcome to my presentation today on the most recent report on advanced recycling technologies, which was published in February this year. And with this slide, I want to show you what the report has to deliver and can offer you. In general, we are updating this report on an biannual base. And you see here also in comparison between the report from 22 and 24. And by comparing only the sheer numbers, you directly realize that we have implemented this year a massive expansion into the direction that we have added much more company profiles and even expanded the focus of the report by including now worldwide statistics about the input and output capacities worldwide. So what has the report generally to offer? So first of all, we are giving an overall overview about all the available advanced recycling technologies. So in the next slide, I will introduce them quickly. So you will fully understand what is the full spectrum of advanced recycling, how the technologies work. We also provide some process diagrams. So if we have time at the end of my presentation, I have put them also in the appendix to show you. But I need to save time today, so therefore I didn't include it in the main presentation. What has the report to offer you also is that we have included many company and technology profiles. With many, I mean that we have more than 100 technology providers of advanced recycling. And for each technology provider, we have a full company and technology profile, which I will also show you on an exemplar as an example for one company. And then, as I said, last but not least, as a very new addition to the report, we have covered the worldwide statistics on the input and output capacities of advanced recycling. So let's start with the overview about advanced recycling technologies. So we came up with this graphic to show you the full spectrum. And yeah, so with advanced recycling, we have a very huge toolbox available in order to address different kinds of waste streams and transform them into a range of different products that can be reintroduced at different positions along the value chain of plastics. So we not only have material recycling based on conventional mechanical recycling, so we have also advanced recycling technologies for material recycling. So this would be a dissolution technology, which is based on physical processes. The dissolution technology usually addresses polypropylene and polyethylene, and here you can utilize a solvent in order to dissolve your targeted polymer. You can remove additives and fillers which are not going into the dissolution from the waste stream. You can also remove contaminations, and then after you have removed and separated all the other components of the plastics, you would usually add an anti-solvent in order to precipitate your targeted polymer, and then you have at the end of the process an purified polymer, purified from the plastics, and you can directly use this polymer. So this could be a huge advantage in comparison to the other technologies, because here you usually have very short recycling cycles. And then we have a very broad range of chemical recycling technologies. So starting with depolymerization technologies, we would have an enzymolysis. So here you are utilizing enzymes in order to break down a targeted polymer into its building units, so its monomers. And at the end of the process, you need to purify this monomers. This is a very critical step, because after this, you would like to go into the repolymerization so that you are able to obtain the polymers again and introduce them again into the plastics. Then we have solvolysis. This is a purely chemical process. Here you are utilizing, depending on the polymer, suitable solvents. Usually solvolysis addresses PET or polyurethane. Again, you break down your polymer into its building units, then you are distilling them in order to purify them, and in order to go into the depolymerization. But also you can utilize, instead of solvents or enzymes, simply an elevated temperature. So in presence of heat, some suitable polymers can be depolymerized. So this is usually done with polystyrene. So you are obtaining the monomers, and then they can be repolymerized again. Then we have a range of different conversion technologies. So these are all thermochemical processes. So here you can utilize the pyrolysis. So in presence of heat and absence of oxygen, you are able to address highly heterogeneous waste streams, but usually pyrolysis addresses polyolefins. So these are the polymers of interest. So there was a question to Jillian asking what's about PET and polyamide. So this is also very often asked to me. Yes, for sure, there are processes who are able to accept this kinds of polymers to a certain extent. So this is also true even for PVC. but the pyrolysis process still has its limits regarding these polymers, and usually the majority of pyrolysis processes are addressing polyolefins. So I hope this answers the question. So usually you are transforming these polymers in presence of heat and absence of oxygen into a range of different products. It can be naphtha, it can be pyrolysis oil, syngas, or even carbon black. And these products, not all, but some of these products can be then reintroduced in the value chain of plastics. Here in this graphic, especially naphtha is highlighted. Then we have gasification, where you transform your mixed plastics waste in presence of the heat and oxygen into syngas, and this can be also further processed into plastics again. So, and then in a wider sense, also incineration is included if you would apply carbon capture and utilization. But here at the moment, we don't have many technology providers out there who have completely closed loop recycling to offer. So let's go further through what the report has to offer. So, and I also want to highlight here the new mapping what we have performed. So in order to be able to really mirror what's happening worldwide, how many plants are installed and where we are standing with advanced recycling. So for this, we have mapped overall 340 plants worldwide. So this not only includes the existing plants, which are installed and running, but also the planned plants, also within the next 10 years, for instance. We not only mapped the plants, we also mapped the parameters of the plants. So this includes the location, the technology type. So we not only have these main technologies, we have also subcategories of these technologies. For instance, we have catalyzed pyrolysis, we have hydropyrolysis. We not only have solvolysis, we have also alcoholysis and glycolysis, and so on. So we also categorized the technologies exactly as it was possible. Then we have mapped the startup year or the intended startup year for the plant, the processed polymer or waste type, so how is the waste composed, as well as the input capacity and output capacity divided into polymers, monomers, naphtha. Then we have a collection term, SVC. This stands for secondary valuable chemicals. This is more or less a pool of different products. It includes pyrolysis oil, carbon black, wax, and others. For these products, it's not completely sure which final route they will take. So it's more or less on the side of maybe open loop recycling or closed loop recycling. So it's somewhere in between. So you are not completely sure if it's open or closed loop. And then we have a category of energy and fuels. So today I am showing you only the results with the focus on Europe. But of course, we have such kind of information in the report for worldwide and other regions. So in Europe, we have mapped or we have found that there are 67 installed plants. So to give you a rough idea, what's the worldwide context? So worldwide, we have nearly 230 installed plants. So, but still for Europe, a very considerable amount of installed plants. So this already indicates that Europe is a very innovative region and is also a kind of a forerunner of advanced recycling. So, and if we look closer, how it divides between European countries, we see that the majority of installed plants are located in the Netherlands, closely followed with 8 plants in Germany, 7 plants in UK, and 6 plants in Spain. So if we look in the input capacities, we directly see, so we have an overall input capacity of 358 kilotons per annum in Europe. If we now look into the breakdown of the different technologies, we see that the majority of input capacity is covered currently by pyrolysis, followed by solvolysis, and then dissolution, and enzymolysis has currently the lowest capacity. Now we look into the output capacities for Europe, and this is very interesting if we set this also into a worldwide context. So in Europe, we have an output capacity of 271 kilotons per annum. And if we now look into the products, we see that 41% of the products, so polymers, monomers, and naphtha, can be utilized for the production of new polymers and plastics. And worldwide, we see a completely different picture. So the majority of the outputs in a worldwide context are fuels, and only 28% can be utilized for the production of new polymers and plastics. So this is very, very impressive to see that Europe has really a strong focus on closed loop recycling by utilizing advanced recycling technologies. So if we now look into the future and maybe also the past development, so we see a very, very strong growth regarding the production capacity. So the graph you are seeing, the data is based on the announcements of future plants which are being announced. So it's not 100% proven that they will be built and will crystallize, but this gives you a very, very rough idea that many things are in the pipeline currently for Europe. And we can expect in the next years very strong growth. So until 27, the production capacity of advanced recycling will be quadruple for EU. And in a global context, it will only double until 27. So, and if we now look specifically on the technology, we are expecting the strongest growth for pyrolysis, followed by solvolysis. And now, very quickly, I want to show you an exemplary company profile, how it looks like. So I cannot show you all 130. So only to give you a quick impression how it looks like. So this is a typical company and technology profile. As an example, I show you today the österreichische Mineralölverwaltung, OMV. So each company profile has a header with quickly accessible information. Here you find the most important data. Then we have a company and strategy profile. So here you learn more about the company roots, what's the main business. You learn more about recycling technology and strategy, as well as installed plants, demo plants, and so on. And then we have a chapter about the technology. So here we are describing the technology based on patent research and also interviews with the company. And as a last part, you find more information about the history of partnerships, joint ventures, and associations. So this is the table of content of the report, that you get an overview about the contents, the specific ones. And with this, I want to thank you for your attention, and I'm open for questions.
Yeah, many thanks, Lars. We have indeed some interesting questions here. The first question is, can you give a view? Can you give a few examples about what kind of companies would be benefiting from accessing this report? What is the target group for this report?
Yeah, so it can be various. If I look on past customers, the customers or the interested parties could come from very different sectors. So first of all, it could be the chemical industry who is interested in this report, because The chemical industry is definitely interested in feedstocks. So maybe they are looking for providers for pyrolysis oil. And this would be very interesting to see the candidates, what players are out there to obtain some pyrolysis oil, in which qualities, or maybe even in which quantities. Such companies could also be interested in collaborate with very interesting candidates. But as a very first step, it's very important to get a better idea what is the concept of the world technology, because they are all completely different. So this would be one aspect. The other aspect would be we have also maybe some waste collectors who are interested in installing an advanced recycling plant on their recycling plants in order to complement their mechanical.
We have so many. Thank you. I think also investors are an interesting group.
Investors also definitely. So we have very, very different groups. So it's really difficult to make them.
I have a lot of technical questions. Perhaps you can give a short answer. We have 2 minutes left. The first question is, how do you include the methanol route in the advanced recycle global picture? How important is methanol here? I think mainly for depolymerization. No?
So for methanol route is not that popular at the moment for the technologies that are currently included in the report. But I'm pretty aware about the methanol route. So last week we had the Advanced Recycling Conference, and there I met at least one very interesting new technology startup who is focusing on this methanol route. And I think in this regard, we will definitely expand also the possible routes of advanced recycling. And another thing is also, we will also have a look next time in the next update it will be in 26 on the open loop recycling. So we have already updated also the overview which I showed you in the first picture in the direction also of open loop recycling. So there are many interesting routes, but today I was not able to show you this.
But I think the breaking down PET by depolymerization, the methanol is used and included in the report already, of course.
Yeah, this is included, but methanol route in regard to the products. So this is an additional route that will come, and there is a startup working on this. So this would be very interesting also to see.
Yeah, there's one. There are 4 questions. I try to cover them as quickly as possible. In the Netherlands, 5 recycling companies have applied for insolvency because the virgin plastic price is simply too low. How is it taken into account in the report, and which factors do you see influence the future of European recycling companies?
Yeah, so this is not currently, so the companies you are referring to is this news are not included in the report because it happened after the publication of the report. But of course, this will be updated if it's still valid in 26. We will also highlight this, definitely, also the bad news. And the main problem here is the competition with virgin material. So this was also part of the press release, but they are still being supported by the government. And let's hope that also the political framework will change in the near future, especially in view about the mandatory recycled content. So I think the market can and will change if we consider also the political framework, and then we will have in the next years a completely different picture.
For the political framework, it's so important. What will Brussels decide? Which kind of recycling technologies are accepted in the recycling quota? And this looks very promising, and that would also create new markets, of course. So I will very quickly go to the other questions here because the time is running. How about decomposition by catalyst instead of enzymes? I think mainly you have described catalyst system and not enzymes. Enzymes are only 1 or 2 companies.
Catalysts are included in several technologies, so we don't have a specific category for catalysts. So catalysts will appear in pyrolysis. They will also appear in solvolizes. So sometimes they not only utilize solvents, they utilize solvents plus catalysts. So if we have information on this, this will be also described then in the specific technology profile. So this is included.
Yeah, and I will very short, PVC recycling. Do you really see options for PVC recycling? I think at the conference last week, we saw several options, so that's also going on. And the last question is on process temperature, pressure, energy consumption, technology. So all detailed information you need for LCA. We gave an overview in the last conference. There's only a few studies available, and I think we cannot easily include all the information in the report because it's not available, Lars, right?
Yeah, so we tried our best. So if we had insight in patents, then of course we can be more detailed. If we also got more information from the provider itself, then we included. So we tried to be for each technology as detailed as possible, but mainly based on publicly available information and some insights by interviews. I think we tried here the best to deliver as much information as possible.
Yeah, many thanks, Lars. We have still ongoing new questions, but if you want to have contact to Lars, please send the question directly to him. You see the email, or to me, I can pass it over so that we can continue the discussion. But now we have to move to the next speaker. Next speaker is Pia Sosinski. She is doing the biopolymer report. You have to stop your screen sharing, Lars. Yeah, thank you. She's doing this report since many years, and it's far the best information worldwide you see here. And I'm very happy that Pia can give you a short overview about this very important report. Pia, you have the floor.
Yeah, thank you very much, Michael. Hello, everyone. And now, yeah, it's my turn for you to present you the key findings of the current issue of our annually published bio-based building blocks and polymers report. And this report covers the market data for 2023, so the current issue. And here we cover the current market data and the market development of 16 bio-based building blocks and 17 polymers, altogether on over 430 pages. And this issue that was published in March this year also includes, beside the market data, a dedicated chapter on mass balance and attribution products that are currently available worldwide based on an extensive analysis of the ICC Plus database. We also have a detailed chapter on biodegradability and biodegradable polymers. So here you can see a list of all available certifications on biodegradability of polymers. And we also included in this issue a detailed elaboration on the current EU policy for bio-based polymers. Today, already a large variety of building blocks and polymers can be produced from different kinds of bio-based feedstocks. And you can see here the highlighted building blocks and polymers in bold that are covered here in this report that are currently available already on demonstration and commercial scale. So 16 bio-based building blocks and 17 bio-based polymers. So we start with the bio-based building blocks and the production capacity. In 2023, we had a worldwide capacity of these 16 bio-based building blocks of 5.3 million tons. And this capacity is expected to increase to 11 million tons until 2028, thereby reflecting a compound annual growth rate of 16%. What happened from 2022 to 2023? We had a capacity increase of about 1 million tons. And the main drivers for this capacity increase to 2023 were mainly worldwide expansions for lactic acid capacity, as well as worldwide expansion for Naphtha, and the production of bio-based ethylene. And we also saw an Asian expansion in the production of epichlorohydrin. Until 2028, bio-based building blocks capacity is expected to increase to over 11 million tons. The main drivers here, or the main foreseen drivers here, are 1.5 pentamethylene diamine as a building block for bio-based polyamides. But we also see a capacity increase, or expect a capacity increase, for succinic acid, as well as 1.4 butanediol, also for lactic acid and monopropylene glycol. And additionally, a capacity increase for the furan derivatives, and we group them here and include 5-chloromethylfurfural, 5-hydroxymethylfurfural, 2.5 FDCA, as well as FDME, all together here under the name furan derivatives. But in the report, you find also all the producers and capacity for the individual furan derivatives. Before I now jump to the bio-based polymer production capacity in 2023, I would briefly like to highlight the collaborations that we are doing regarding bio-based polymers market data. So since 2016, we are supplying or providing the bio-based polymers capacity data to European bioplastics for their annual bioplastics data. And since last year, we are also collaborating with Plastics Europe and also providing here data for bio-based polymers and plastics, together also with data for chemical recycled plastics as well as CO2-based plastics. And as you can see here, from these three different figures, the overall volumes that are published by the three parties differ a little bit. So Plastics Europe for 2022 published a worldwide bio-based polymers and plastics production of 1.9 million tons, European bioplastics of 1.5 million tons, and we as Nova published bio-based polymer production in 2022 of 4 million tons. And the reason for this difference in the overall volume is quite simple, because every one of these three parties has a different scope concerning the polymers that are included in the data. So we as Nova publish data on all of the 17 currently available bio-based polymers and their application in 10 different applications. European bioplastics, on the other hand, only includes in their scope 14 bio-based polymers in the 10 applications. And on the other hand, we have Plastics Europe. They only have 16 bio-based plastics in their scope, referring to 8 applications. So now coming back to bio-based plastics production and starting with an overall plastics production in 2022. So the overall worldwide plastics production was at 386 million tons in 2022, whereby 4 million tons were made up by bio-based polymers, reflecting a bio-based share of 1%. And if we go back to now to 2023, so bio-based polymers production capacity in 2023 was at 4.8 million tons. And these capacities are expected to increase to over 10 million tons in 2028, and thereby reflecting a compound annual growth rate of 17% for these 17 bio-based polymers. From 2022 to 2023, what happened? So we had a capacity increase of about 500,000 tons and an increase in the actual production of 400,000 tons. And the main drivers for this increase to 2023 were mainly Asian expansions for polylactic acid capacities as well as for polyamide capacities. Additionally, Asian expansion for epoxy resin production was increased, and we had an increase in the South American capacity for the production of polyethylene, as well as a worldwide increase of the polyhydroxyalkanoate production capacities. Until 2028, bio-based polymer production capacities are expected to increase to 10.5 million tons. And also here we have main drivers for this increase, mainly again Asian expansions for polylactic acid as well as for polyamide. We also see worldwide expansion for polyhydroxyalkanoate capacities, and there will be new installations for the production of bio-based polypropylene, mainly in North America, and also an Asian expansion for epoxy resin production. When it comes to the bio-based polymer production worldwide in 2023, we were at 4.4 million tons, whereby the largest bio-based production share was made up by cellulose acetate and epoxy resins, together making up over 50% of the bio-based production in 2023, followed by polylactic acid with 11%, polyamides with 8%, 7% of the bio-based production were made up by bio-based polyurethanes, and we have with a share of 5 and 6% bio-based polyethylene production and bio-based polytrimethylene terephthalate production. The share of the other bio-based polymers that are listed here, so PBAT, polyethylene terephthalate, polyhydroxyalkanoates, as well as starch-containing polymer compounds, was below 5%, and the bio-based polymers that are listed here at the bottom are not included in this picture here for visualization. So these bio-based polymers here had a share in the bio-based production of less than 1%. When it comes to the regional split of the global production capacities of the bio-based polymers in 2023, the largest share of installed capacities was in Asia with 55%, mainly based on the installed capacities for polylactic acid and polyamides, followed by North America with 19%. Also here, mainly based on installations for polylactic acid, but also based on capacities for polytrimethylene terephthalate. Then with 13%, mainly based on polyethylene capacities, is South America, and also Europe had a share of 13%, mainly based on installed capacities for starch-containing polymer compounds and polyamides. And last but not least, with the share of less than 1%, we had Australia and Oceania, mainly based on installations for the production of starch-containing polymer compounds. And with an expected compound annual growth rate of 35% between 2023 and 2028, Asia displays the highest growth of bio-based polymer production capacities compared to the other regions of the world, and this increase is mainly due to higher production capacities of polylactic acid, polyamides, and polyhydroxyalkanoates. So when it comes to the different applications of the polymers in different market segments in 2023, the highest share of the bio-based polymers went into fibers with 27%, mainly based on the use of cellulose acetate and polytrimethylene terephthalate. The fiber segment is followed by the packaging sector with a total consumption of 21%, whereby flexible packaging made up 18% and rigid packaging 13%, mainly based on the use of polylactic acid and polyethylene. The functional applications with 17%, mainly based on the use of epoxy resins and polyurethanes, followed with 10% by the automotive and transport segment. Main bio-based polymers used here are polyamides, epoxy resins, and polyurethanes. Then with 9%, we have here consumer goods, and this includes, for example, coffee capsules, bio-waste bags, leisure, and interior. With 9%, mainly based on the use of polyamides, but also epoxy resins and polylactic acid. The building and construction segment had a share of 6%. Here, mainly epoxy resins and polyurethanes are used, electrics and electronics with 5%. Also here, mainly the epoxy resins, but also polyamides are used in this segment. 2%, a 2% share had the agriculture and horticulture segment. Here, mainly polylactic acid and polyamides find its application, and also 2% went into other applications, and this include films that are not used in agriculture and horticulture, but also 3D printing, medical applications, and aquaculture. And the main bio-based polymers used here are polylactic acid and PBAT. And yeah, with this, I'm at the end of my presentation, and everything that I showed you in brief on the slides before is in detail included in the bio-based building blocks and polymer report. And if you would like, as Michael already mentioned, we have a freely available short version of this report. There you can find all the highlights that I also showed you on the slides before. You can just click on the link here and you will be directed to the report and the respective short version. And yeah, just if you are interested in purchasing this report or any of the other reports, do not forget to use your 20% discount code until January 2025. Thank you.
Thank you, Pia. It was very good in time, so we have a lot of time for questions, and we have many questions, so that fits well. I'll start with the first question. Evaluation of mass balance attribution only based on ISC Plus database. Other options, RedCert, RSB, are not included here?
No, they are not included here because, to be honest, ICC Plus has the most transparent database with the listed certificates. So we based our statistical analysis on the ICC Plus database. But for the new data that we will publish in March 2024, we also did an extrapolation based on the certificates that are included in the other databases and certifiers. Yeah, so we will give a more elaborated number next year, where we also include an extrapolation based on the market share and the certificates that are out there, also from the other certifiers.
But the error is not too big because ICC has a by far highest share in the certification. So I think it would be a good way to start with ICC evaluation. The next question was, why do you mention MPG and not MEG in your growing forecast?
Because for 2023, it's monopropylene glycol had the largest increase in forecast in the capacities until 2028, and not so much monoethylene glycol. But this might change as well for the 2024 data, yeah.
And there are several questions on the inclusion of PBAT. The first is, how do you account for PBAT and starch-based polymers in China? Do you include fossil-based PAT in your assumptions? And the other question is, PBAT seems much smaller in the graphic than in reality. I assume only bio-based volume taken into account. Can you comment on that?
Yeah, that's correct. So we, for PBS, and for PBAT, we only include the bio-based PBAT and PBS in this report. And but I think Anne, in the presentation afterwards, she also included the fossil-based PBAT. Yeah, we are aware of this, but we decided, I think last year or the year before, that we will focus on bio-based PBAT and PBS. Yeah, to just give a more precise picture of the bio-based polymer market.
And we'll show more later in the next presentation more about it. Then another question was inclusion of bio-based or biodegradable. I think the focus is bio-based, but we have in the bio-based family also specific data on biodegradable polymers, right?
Yeah, we have. So we have in the full report, at least, or maybe also in the short version, I'm not sure yet, we also have a split between the bio-based non-biodegradable polymers and the bio-based biodegradable polymers. Yeah, but the major focus is here bio-based.
Yeah, and then the question here, I got to read it. I don't know whether the numbers are quoted right, but perhaps you know it, Pia. In its latest Plastics, the FACT 2024 report from Plastics Europe, they mention 0.3 million tons of bio-based plastics in 2023. Does that figure come from Nova? Does it include bioattribution? There's a relatively small number from 23.
Yeah, it's a relatively small number, but yes, the number is coming from us. But as I explained on the slides before, Plastics Europe is having a completely different scope than we have. So they only cover 16 polymers, and also they do not cover all the applications. So what is completely out in the Plastics Europe figures is, for example, cellulose acetate and also epoxy resins, because cellulose acetate is mainly going into fibers, and that is out of scope for Plastics Europe because they are covering plastics. And the same is true for epoxy resins that have a large application share in functionals, which is also not in the scope for Plastics Europe. And yeah, Plastics Europe is also publishing bioattributed numbers. Yeah, but I think they show a split between bio-based and bioattributed. Yeah.
Yeah, and there's more political question here, but interesting to discuss. And I can also give later my comment on that. What are the reasons of European having a relative low share, only 13% in the bio-based polymer capacity? Yeah, why Europe is so poor here? What is your comment on that?
For 2023, it was also not a yeah, let's say numbers issue. We also, for example, for starch-containing polymer compounds changed the methodology a little bit, because as you might know, starch-containing polymer compounds are compounds made of thermoplastic starch, and then other bio-based or also fossil-based polymers, for example, PBAT, PLA, PHA, or PBS. And we were also struggling with some questions in the past that we have a double counting for the starch-containing polymer compounds, and therefore we changed the methodology for them. So we just were publishing the overall capacity for the starch-containing polymer compounds based on the thermoplastic starch content, which is 30%. And the majority of the starch-containing polymer compounds are produced in Europe, and therefore the number for Europe was decreased in 2023. And the other aspect was the European production for polyethylene and polypropylene, where we assumed in the years before that we had a much larger share of, let's say, real bio-based polyethylene and polypropylene. And since last year, we know that this overall figure is less for bio-based production, because the majority is bioattributed. And therefore also we had to decrease the overall numbers for polyethylene and polypropylene. Yeah.
And another big reason is that there is almost no additional investment in Europe in new capacities. And this is mainly because of the missing supporting policy framework for bio-based solutions in Europe. We saw civil investment going to Asia because of better framework and support, or also to US. And we really hope that this will change the next years again. We're working very close in Brussels to change this. So this is, I think, the main reason why we're not seeing a big growth in capacities in Europe, next to the reasons, fine-tuning reasons Pia just mentioned. Yeah, okay, we have a lot of additional questions. Perhaps I can take one in addition. Yeah, what is about there's so many open questions here. Yeah, recycling is recycling values are included in the other report. That's right here. Yeah, then the question also whether we are in line with the GIL report on bio-Naphtha when we here calculating the mass balance approach values. I think you are in close contact. GIL is also part of the team. So the other question going off too far in our time limitation. So please send the questions again to Pia or me, and we try to give you a good feedback here. There are also some misunderstandings, but please send it and we will cover your questions.
Thank you.
Coming now to the last report. Yeah, thank you. To end from China. I think it was very interesting to have also a deep view in the Chinese market. And so I'm happy to that Anne is now available to present her report here. The title is Bio-based Biodegradable Plastics Industries in China. Anne, you have the floor.
Thank you, Michael. Good afternoon, good evening, everyone. Thanks for staying with us until now. I would like to share some of our insights from our latest report on China's bio-based and biodegradable plastics industry in China. This report was published this May. But first, allow me to quickly reflect on doing this report. It took us half year to put this report together. There are mainly two challenges. First, as we know, the Chinese market is huge, with hundreds, if not thousands of players in the market. And second, the bio-based industry itself is still emerging. So there is no clear industrial taxonomy to categorize and monitor and check the market data. Although this is not only the issue in China, as I know. Luckily, thanks to Nova team and our Chinese partners' help, that makes this report possible. Second, I want to note that this is our first time with a deep dive into the Chinese market. It might not cover everything, but I believe it gives fresh insights and solid overviews of the industry in China. And additional, as Pierre just remind, I also would like to remind for some of our audience, if you're not very familiar, the distinction between the bio-based plastics and the biodegradable plastics. In this report, we defined the according to the EU's the definition. The bio-based plastics are wholly or partly derived from the biomass feedstocks, but they are not necessarily biodegradable. While the biodegradable plastics can break down through the microbial activities under certain conditions, but they are made from either the biomass feedstock or the fossil feedstocks. So, and then I would like to share more details about this report. Okay, I will break down into 4 parts. First, introduce the bio-based plastic market and the relative key policies, and then a little bit mentioning about the market size and the growth in the biodegradable plastics sector, and then the key findings and the summary. So if we look at the whole plastic industry in China, this industry grows dramatically fast since 1990s, from the 2 million tons to until 2022, 130 million tons. And I think this one of the reasons, thanks to the globalization, and especially when China joined the WTO since 2000, this growth really we can see grows fast. And now China is the world's largest contributor for production and export the plastics worldwide. And this is a map. We know that last year totally is 400 million tons, and China occupied 33%. And then yeah. This is a China bio-based plastics market. We mainly select the majority marketing materials in China, which also the data is available there. So it covers PET, PET, PF, PEF, PHA, PTT, PLA, and PA. So this market also experience, if we see the figure, it's grows rapidly. Despite, I would say, it's still in its in the industrial life cycle, it's still in its early stage. I will explain this a little bit later. And we estimate it will reach to 2.5 million tons by 2026. And from the current 765,000 tons. And the average growth rate is 49%. And among these polymers, the polyamide, the polylactic acid, and the PHA are the top three faster growth plastics, which we estimate the compounding average growth rate with 70%, 40%, and even 100% respectively between the two 2023 and 2026. And then let's look at the key policies which influenced the bio-based plastics industries. I just classify it as three types different from the top. The criteria like on the top, the strategy is more focused on the climate change, which in China is called the dual carbon goal, which the government released in 2020. Generally, the goal is by 2030. The carbon dioxide emission will reach to its peak. And until 2060, China will reach the carbon neutrality. And actually, according to our study, by 2024 this year, China already achieved its current target. And then I would say, because from our findings, the Chinese government supporting this bio-based industry is due to the two reasons. The one driver is, of course, the climate change. And the dual carbon strategy is very clear to set up the goal, and even for the individual departments, ministries, all have that breakdown goals to reach the targets. And the second reason is because the national security strategy. As we know, because the oil or petrochemical industry in China is a pivotal industry, which contribute around 20 or 25, if I remember correctly, % of GDP in China, which is very important. But this industry is heavily rely on the importing oil so far. And there is an estimation by 2023, there are around 75% oil will be imported. So this is a second reason the Chinese government would like to find the alternative feedstocks to replace the fossil-based feedstocks. And then following these two major strategies, by 2020, the Chinese government issued the first national bioeconomy strategy. I think there is a typo here. I write 2016. Actually, this strategy, this national development plan under the 14th five-year plan was issued in 2020. Because of this bioeconomy action development plan, the whole industry, the bio-based industry, was really rocking up. And after the 2 years, the government also issued a detailed action plan addressing the use of the non-food crops and non-food biomass as a feedstocks. So I would like to a little bit let's delve into this action plan to understand why now in China it looks this industry is very promising thanks to this the policies. So the goal for this action plan is to promote the non-food biomass to produce bio-based materials. It's aiming to compete with fossil-based products by 2050. That was written on this document very clearly. And the objective I just cite with an abbreviation for several of the key inputs there. like developing the large-scale saccharification technology. The lactic acid production scale will reach to 100,000 tons. DN5 PHA's production scale to 10,000 tons. And 5 core competency companies with 3 to 5 bio-based industrial clusters. I want to go through all these details. You can see yourself, but I would like to see this action plan is it's not like a Euro government document, because this time it's really give a very defined specific technology guidelines for the Chinese companies. During our interview with those companies, we heard very positive feedbacks from the entrepreneurs about this action plan. They quite believe this really gives their confidence to drive their business growth. So in summary, for the bio-based plastics industry in China, we project the market size will grow to 2.53 million tons, with a compounding average growth rate reach to 49% by 2026. The key drivers behind could be summarized as the first one is government industrial policy is very strong. And the innovative technologies, as we all know, the biotechnologies, especially the synthetic biotechnology, is one of the focus areas in China now. And also the very strong funding system. This funding system, I would say, the private equity and the venture capital is more active than government public funding in China. And then the feature of this industry, we can see it's like a faster growth market, but it's still at the industrial life cycle early stage. It's new, and I think this industry needs to be protected, and it's not a tariff protected, but more like the niche market to be protected in order to let them grow healthy and to be compete with a fossil-based industry in the future. That's my viewpoint. And then let's look into the biodegradable plastics market. I need to check my own time. Okay.
We have 4 minutes.
Okay. The segment actually remains quite well around 12% between the 2016 to 2020, because that time there is also some cities and provinces issue some the ban the single-use plastics regulation or the guidelines. But the volume is still low until 2020 is a watershed for this industry because thanks to the policy incentives since then the market tripled from 500,000 tons to 1 million tons. I'm talking about the product capacity, not the actual capacity, not actual production. It's different, but the production capacity already reached to 1.7 million tons. And we estimate only PLA and PBAT, which is majority products in this market, will reach to 3.6 million tons by 2025. And behind that, the government policy is a significant catalyst to grow this market. However, we assume the projection might be changed in the next. We actually already changed our projection. I discussed this with peers this year. We have reduced some of our estimation for PLA and PBAT. In this market, I will play a little. Just to take an example with this guideline. It's not a directive, but it's like between the communication and the directive in Europe, which we call the plastics restriction guideline, issued by the Chinese government, NDRC, the National Government Development and Revolution Department. In 2020, the title is Opinions on Governance, Further Strengthening the Plastics Management and Control. And the objective in general is to well manage the plastics management system to reduce the use of the plastics and controlling the plastics pollution. And under these guidelines, it gives more details about the target, the milestones in different phases. For example, by 2020, around 30 big cities in China need to ban the non-biodegradable plastics bags. Normally, in the market, in the supermarket, in the hotels, in those places, and will expansion to more cities by 2025. And the other is reduce the non-biodegradable plastic tablewares consumption by 30% on the food deliveries in cities by 2025. There are more about this detailed let's say regulations there. I just gave an example. And also it said to promote the alternatives. In these guidelines, it said clearly to use eco-friendly fabric bags, paper bags, and the biodegradable plastics shopping bags. And we can see, and also the agriculture mulch films are encouraged to use the biodegradable like PLA, PBAT. So we can see since from the 2020, since the regulation was issued, this market is really highly rock up because of this kind of policy, incentive policies. And then I changed to another topic about we made also in this report the companies.
But we have to go to the question part. You have already 60 minutes now.
Okay, yeah.
So please come quick to the end that we can pass some questions to you.
Okay, all right. Yeah, I think it's almost the end of this report. Thank you.
Thank you, Anne, and the audience see that a lot of in-depth information that are available. One question here is, do you have also some data on pricing on costs on the polymer production in China?
Not every. We have some, but we're not. We didn't present in this report.
Okay. So this report is more on market data, not on price development. Then
Yes.
the question is, does China have composting facilities and separate collection systems for PLA? Otherwise, I would argue that the policy to limit plastic waste may not be successful. But what is with the collection of plastics and especially PLA?
Yeah, very good question. Asking for the end of life, the waste treatment, right? If I follow your question.
Yeah.
Sorry. Yeah, sure. This is a really good question. This is still the issue in China. The whole system is not established very well. Although in some big cities like Shanghai, Beijing, or my city, Suzhou, there is already the existed the waste recycling system, but it's not exactly like what Europe, in Germany or Netherlands have done there. But the Chinese government already shift their policy priority. As I just introduced this guideline in 2020, they highly encouraged to use biodegradable plastics instead of that previous PE or the other PP plastics. But after 2 years, there are so many reports, scientific reports, all from the medias, to report that actually in the market it's mess up. There are some fake the polymers to claim they are the biodegradable, but actually they might be the oxy biodegradable, which is not really break down the plastics. And then also the big issue, the industry's inside or experts also point out, because the main reason is a recycling system is not established well. That needs to be really improved rapidly. And also the standards, the label, all these things also need to catch up in order to really fully use this biodegradable. So that's also the reason why since 2000, let's say, 2022, this biodegradable market in China actually was slowed down. A lot of a project was hold off or canceled because they see the Chinese government now shift quickly also to address recycling. Now they said recycling is priority, and also they said need to be more cautious to use the biodegradable plastics in the market, and this is the current situation.
And I would like to cover the last three questions, and I give perhaps a quick answer. And if you have something to add, please do. There was questions on PBAT, was expecting booming polymer in China, and here we can't see it so really. So the reason is that PBAT is mainly fossil in China. Yeah, there is not so much bio-based PBAT.
Yeah.
The other question on PHA. The question is, you say it's also growing polymer, but later you can't see really volumes on PHA. These are the two questions. The last question is, what is the proportion of bioplastic, biodegradable used in China versus export? Can you quickly go to this 3 points? PBAT, PHA, and export and domestic use.
Export, you mean export
How
to...
much of the volume produced is used in China or
export? So far as I know, we interviewed some, because this is not really can be searched from the official statistics, and I said there is no such a industrial taxonomy for the bio-based plastics. But according to the companies we interviewed, or the industrial association, we know most of these, let's say, I assume it could be half to half, but I'm really sorry, I don't have the clear data so far on hand. I would say half to half. I know some export to French and Italy because we know they have some different regulation to support the biodegradable single-use.
I could also see 50-50, but we have to realize that China, of course, had a huge domestic market. If you look to big films, for example, China is far leading in application emulsion films in the world. So some areas they are the main user of those polymers, but of course there will be also exports. 50-50 is a good first guess. Okay, time is running out. Many thanks, Anne. And as a final word, I got already 40 emails for sharing the slides. So I collect all the things and give you then a nice feedback soon. And for those who want to buy the reports, again, we have a 20% discount over the winter in December, up now, December and January. And if you buy a report, we also including a short workshop. So if you need 1 hour discussion on the details on the report, this is included in the price. And what also is important, we're doing, of course, a lot also customized reports. So many companies need specific information. And this is, of course, also what we try to serve next to the public available reports. So many thanks to all the speakers, many thanks to the audience. And if you have still some questions, I'm happy to receive the questions and bring it to the right experts in our team. And again, my email is michael.carus, C-A-R-U-S, @nova-Institut, without an E at the end, .de. So I wish you a nice winter break, and I hope we see you all back in our conferences next year. So have a good time and relax and and recharge your batteries. Have a good time. Bye-bye.
Bye.
Bye.